Alright, so now we're on to number 3, systems of elimination. And your learning target is I can solve for solutions of systems of linear equations by elimination. So let's go through some of the notes here. The first thing we're going to talk about is how the steps that we need to take in order to solve systems using the method elimination. So in order to solve systems using elimination, the very first thing we need to do is to write the system, meaning both equations, so that the like terms are aligned. Okay, so what that means is that we need to have all the x's, all the y's, and all the constants all in the same lineup, right? Now, not every single system that we're given, we're going to need to do this for step 4. Some of them are already going to be lined up for us, but just in case, if there's one that isn't like that, that's the first thing you're going to want to do. Once we have that system lined up, the second step is to eliminate one of the variables and solve for the other variable. Okay, and we can eliminate by adding or subtracting the two systems, the two equations together, okay, in order to get rid of one of the variables by making sure that they cancel each other out. Okay, so one or both of the equations may need to be multiplied in order to get a variable that has the same coefficient, which means the coefficient, remember, is the number before the variable. So we may need to multiply our equations in order to get the coefficients the same. Now the third step is to substitute. We need to substitute the value of the variable into one of the original equations and solve for the other variable. So once we find one variable, we substitute it back into one of the original equations and solve for our other variable. And then finally, we can write the answers from steps 2 and from 3 as an ordered pair, which looks like x, y. Alright, example 1 says to solve the following system by elimination. We've got two equations here. We've got negative 8x plus y equals 17 and 3x minus y equals a negative 2. So let's go back to our step 1. Our step 1 says to write the system so that like terms are aligned. And if we go back down here, we'll see that negative 8x or these two equations are already lined up. The x's are all lined up together, the y's lined up together, and the constants lined up together. But what I'm going to do is I'm going to go ahead and rewrite these real quick, just so we can see things a little bit more spaced out and to see everything lined up just a little bit more evenly. So I'm just going to write these together real quick. And the second step that we need to do, the second thing we want to do, is to eliminate one of the variables and solve for the other variable. And if we go back down here, we'll see again that one of these is very easy to eliminate. If we were to add or subtract these two equations together, our y's would cancel out if we added them together, right? Because they're opposites to each other. This is a coefficient of 1, coefficient of 1. This one's positive, this one's negative. Put them, combine them together, and they make nothing, right? Which is our whole goal, okay? So we're going to eliminate our y variable by adding the two equations together. And when we do that, these will cancel out, and we'll be left with a negative 5x is equal to a positive, this is a positive 15. Okay, now we just finished solving for x by dividing by a negative 5 on both sides. We end up getting x is equal to negative 3. Okay. Now the third step is to substitute the value of the variable into one of the original equations and solve for the other variable. So now that we know x is negative 3, we can substitute it into either one of these two equations, doesn't matter which one, and solve for y. Okay, I'm going to choose this equation, the 3x minus y equals negative 2, and because I feel like this equation uses smaller numbers, it might be a little bit easier to kind of see what's going on. So I'm going to go ahead and write that equation, 3 times x, which remember though, x is negative 3, minus y equals a negative 2. Okay, now I can solve this equation for y, and I'll have the value of x and y. So 3 times negative 3 is a negative 9, minus y equals negative 2. I need to add 9 to both sides. and I'll get negative y is equal to 7. Now I don't like my variable being a negative number, so I'm going to multiply by negative 1 on both sides in order to get rid of that negative, and I'll be left with y is equal to a negative 7. And so finally, this last step is to write our answers from steps 2 and 3 as an ordered pair. And so what we have for our answer is that x is negative 3, y is negative 7. And that's the answer to the system of these two equations. Alright, example 2 says solve the following systems by elimination. Now remember, our first step is to write the system so that like terms are aligned, and we see like terms are aligned. But the second step would be to eliminate one of the variables, but we cannot easily eliminate any one of these variables, and the reason for that is because none of these just cancel each other out. They have different coefficients, and so what we have to do is we actually have to multiply one or both of these equations in order to be able to get rid of one of these. Okay, and what we see here is that 2 goes into 6 3 times, and 5 also goes into 10 2 times. And so what we can do is we can just multiply this top equation by either 2 or by either 3 in order to get these equations lined up. Now I'm going to multiply this top equation by 2, because then I will have 10x for both the top equation and the bottom equation. Okay, so I'm going to go ahead and rewrite this other equation, 5x minus 2y equals negative 11. And I'm going to multiply everything by 2 in order to get this lined up a little bit better, right? 5x times 2 is 10x, negative 2y times 2 is negative 4y, and negative 11 times 2 is a negative 22. Now I have some equations that I can work with, right? So I'm going to write this equation instead of this equation. I'm going to line everything up again. 10x minus 4y equals a negative 22. And our second equation, which is 10x minus 6y equals negative 18. Now remember, last time we added these together, the two equations together, and if we did that, we would get 20x, so that's not going to work. But we can also subtract the two equations from each other. Okay, so I can subtract the two equations from each other, and that will also be a form of elimination. 10x minus 10x is nothing, right? That works, so we can cancel those equations out. Now we have a negative 4y minus a negative 6y. Negative 4 minus a negative, remember if you subtract a negative, all you're really doing is adding. So negative 4 plus 6y is 2y. And negative 22 minus a negative 18, so again, subtracting a negative means we have to add. Negative 22 plus 18 is going to give us a negative 4. And finally, we can just divide by 2 on both sides, and we'll end up getting y is equal to negative 2. Okay. Now that we found out what y is, we can go ahead and substitute this back into any of our original equations and solve for x. So I'm going to choose this first equation. Even though we changed it down here, I'm going to choose that first equation. We've got 5x minus 2y, but remember y is negative 2, is equal to negative 11. And all we have to do is combine these or solve for x now. Negative 2 times a negative 2 is a positive 4. So we have to subtract 4 from both sides. We're going to end up getting 5x is equal to a negative 15. And then we'll just divide by 5 in order to get x is equal to negative 3. So our answer for this is negative 3, negative 2. Alright, now let's do example 3, and we've got negative 2 plus 7y equals 9x, and 8x equals 16 plus 4y. We can see this is not really laid out very nice for us, and so we want to reorder the terms so that all the like terms are going to be lined up. So we've got negative 2 plus 7y equals 9x. A good way to do this is to get each equation in standard form. And so let's go ahead and subtract 9x from both sides. And let's go ahead and add 2 to both sides as well. Because if we do that, we're going to get all the constants on the right side of the equal sign and all of the variables with their coefficients on the left side of the equal sign. Okay. Now we have negative 9x plus 7y equals a positive 2. Okay. Now let's go ahead and change up this second equation. We've got 8x equals 16 plus 4y. In order to get all of the variables on the left side, we just have to subtract 4y from both sides, and we'll end up getting 8x minus 4y equals 16. Now things are lined up a little bit better. But the only problem is that our x's don't have, 8x doesn't go into 9, or 8 doesn't go into 9, and we see 4 doesn't go into 7, so we're going to have to do a little bit more work for this. We're going to have to multiply both equations to get both of them into a common number, right? I, again, like to choose the smallest numbers possible, and so we can get 7 and 4 to be the same exact number if we multiply this equation by 4 and this equation by 7. And so let's go ahead and do that. We're going to multiply this equation by 4. And negative 9x times 4 is going to be a negative 36x. 7y times 4 is going to be a 28y. Is equal to 2 times 4, which is 8. Do the same thing over this on this side, except we're going to multiply by 7. We get 8 times 7 is 56x. Negative 4 times 7 is negative 28y. And 16 times 7, if you might have to use a calculator for that, that's going to be 112. Okay, now we have a negative 28y and a positive 28y. We can actually do some elimination. So let's go ahead and move this equation under this one. We've got 56x minus 28y equals 112. And we can add these two equations because if we add them, the 28y's will cancel out. These are going to cancel out. Negative 36x plus 56x is just 20x. 8 plus 112 is 120. Just divide by 20 on both sides. And we're going to end up getting x is equal to 6. Alright, we found x. Now we have to go back and find y. So we're going to plug the value of x, which is 6, into any of our equations that we found, any of our equivalent equations. I'm going to use one of our original ones. I'm going to choose this top one because it's the smallest number. So we've got negative 2 plus 7y equals 9 times x, which, remember, x is 6. So multiply 9 times 6 first. That's going to be 54. We just have to add 2 to both sides. We're going to get 7y is equal to 56. And then finally divide by 7, and we get y is equal to 8. So our final answer for this is x 6, y 8. Alright, so what we wanted to do for this whole thing was to solve systems by using their method elimination. Hope you enjoyed.